Bismillahirrahmanirrahim. So, dear students, so today we'll be talking about the another oxidation reagent where we use ozone. Fine. So, where we use ozone for carrying the oxidation of the organic substrates. तो हमारी जो organic reagent series है उसमें since we are talking about the reagents, we have started the reagents regarding the oxidation. So, we'll be talking about ozonolysis, where our reagent is ozone, that is O3. So if you talk about the ozone, so it's like this is your ozone, so this is your plus and it bears a negative charge. So this is your ozone. So with the help of ozone, how can we carry the the oxidation of the substrates? ठीक है, इसमें जो important बात है regarding the competitive exams, so what actually we have to remember, otherwise ozone is not a difficult topic. देखिए, the thing is that as the word suggests, with the help of ozone we can carry the ozonolysis. So it means lysis, we know it's a breakdown or cleavage. So lysis means breakdown of substrate or cleavage of substrate with the help of ozone. So what it does, it converts your alkene substrates. If you have alkene compounds, that you have C double bond C. So what it does, let me say we have, this is our substrate alkene. So with the help of ozone, what it does, it results in the breakdown of this substrate into carbonyl compounds. Simple. So we have got the breakdown of this substrate, then oxygen has came here, so that's it. So ozonolysis means breakdown of your alkenes, unsaturated compounds with the help of ozone to form carbonyl compounds. ठीक. So अब इसमें important बात ये है, since we know that in the alkene we have one bond, that is your sigma bond, and one is pi. So we know pi bond is a weak bond, it can be broken easily, but ozone, with the help of ozone we can break sigma bond also. ये देखिए, that's why we have two molecules of this carbonyl. So it leads to the breakdown of sigma as well as pi bond. So in ozonolysis we have pi as well as sigma bond breakage. ठीक है? Okay. Now, so what is the result of this ozonolysis? That is so we can say ozonolysis in general is an oxidative cleavage, because we have converted alkene to the higher level of oxidation, that is carbonyl compound or aldehyde. So it is an oxidative cleavage. So this is your oxidative cleavage. So ozonolysis is an oxidative cleavage where sigma as well as pi bond is broken and the substrate, which is alkene, is converted into the carbonyl compounds. That's the definition. Now इसमें जो important बात ये है, so we use ozone, but this ozone can be used under two conditions. One is you can use ozone in presence of peroxide, that's an oxidizing agent, and you can use ozone in presence of dimethyl sulfide, or you can use ozone in presence of zinc and acetic acid. If you use ozone in presence of peroxide, it's called as oxidative cleavage. So that becomes your oxidative cleavage. Oxidative cleavage. And if you use ozone in presence of dimethyl sulfide, or dimethyl sulfide means your sulfur here, CH3, and here CH3. Or you use zinc in presence of acetic acid, it's called as a reductive cleavage. A reductive cleavage. So you are breaking the C double bond C, but then जो सबस्ट्रेट बनता है उसकी रिडक्शन हो जाती है, जो ब्रेकेज के बाद जो फ्रेगमेंट बनता है उसकी रिडक्शन हो जाती है. एंड इन केस ऑफ ऑक्सीडेटिव क्लीवेज, ब्रेकडाउन के बाद जो सबस्ट्रेट जो आपके फ्रेगमेंट्स बनते हैं, दे आर अंडरगोइंग ऑक्सीडेशन. ठीक है. सो नाउ लेट्स टॉक अबाउट द important thing से question आता है, that is the organic transformation. Let's first talk about the scheme, how it happens, then we'll move further. So let's talk about the mechanism first. I feel it is important to go for the mechanism. So this is our substrate. So how it's getting converted to this. So let's talk about the mechanism. Mechanism of ozonolysis. Then we'll see how the oxidative and reductive will work. So mechanism. So this is our substrate, that is it's 4 methyl groups, 2 methyl groups on this carbon, 2 on this, and we have unsaturation here. So this is treated with the ozone. So how it reacts with the ozone, that we'll see. Let's do it in the single step rather than wasting time. It's oxygen here. So this is your negative and this is your plus. This is double bond, that's ozone. Okay? So what it does, so this bond attacks here, fine, and then we have a positive charge on the oxygen that gets removed with the help of this bond shift, and this negative charge attacks on this carbon. Now this is basically a concerted mechanism. Since we have 1, 2, 3, first oxygen and third oxygen all attacks on this double bond, so it's like a cycloaddition reaction. Remember, it's called as, it's a 1,3 cycloaddition kind of reaction. It's very, very important to remember. So it's 1,3 cycloaddition. इसमें क्वेश्चन इस तरह से आते हैं, 1,3 cycloaddition. So it's basically the ozone adds through a concerted mechanism, single step. ठीक? So what it forms is, this is your what's formed. ठीक? Now this ये जो structures का बनता है, this is called as a mole ozonoid. Mole ozonoid. It's not ozonoid. Sometimes we make the confusion that we say it's a ozonoid. No, it's mole ozonoid. Then this gets rearranged to ozonoid. So then this mole ozonoid, what will happen to this mole ozonoid is, you can take this bond here and you can convert this into this. So what is formed is, now we have 2 fragments here. This is carbonyl fragment from this portion, and here we have, so this gets a plus charge, oxygen and oxygen negative. ठीक? आप इसे, yeah, this is very important. ये जो आपका fragment बनता है, we have a lone pair here that can stabilize this, and then this can come here. So we can also form the canonical structure of this. That canonical structure is C double bond O. Oh, sorry, what has happened? What it has does, double bond, yeah, keep it here. So you can write it C double bond O. This way also we can write it. Okay? So don't remove this. The ये जो structure है ना, either this or this canonical form, this is called as the Criegee's intermediate. So इस पे भी question आता है कभी. So this is your Criegee's intermediate. Criegee's intermediate. Intermediate. Remember, इसमें we have 2 charges, that's plus and minus. ठीक? So this is a zwitterion basically structure. Zwitterion. So Criegee's intermediate is a zwitterion. We have plus and negative charges on the same intermediate. So it's a zwitterion type structure. Criegee's intermediate is formed in the ozonolysis. ठीक? So what happens after that? Now we have this carbonyl and we have this Criegee's intermediate. So then what happens after that? Let me do it here. So this is your carbonyl. I've just written it, up and down. Then you can show it like this. This was negative charge. This was your oxygen. and this was the plus charge. So what it does, you can attack here at this carbonyl nucleophilic addition, and then you can do one thing, you can attack this carbon here. So what you get is you can show it like this. So down, then you have so you have this oxygen here. So two oxygens, then you have this is your structure formed. Okay. So now अब देखिए, ये तो normally this is what the Criegee's intermediate and structure is. Now the question comes oxidative and reductive cleavage. How it cleaves basically. ये जो carbonyl दो बनते हैं यहाँ पे, how it's basically getting cleaved now. So how it gets cleaved, because अभी तक bond break नहीं हुआ है, ठीक है. So bond has not got broken yet. So it was like this. So what is the difference between, if you talk about this, now oxygen is between here, now we have oxygen is shifted to this position. This is basically conversion of mole ozonoid to ozonoid. This is your ozonoid structure. Now इसके बाद cleavage होता है. For example, अगर आपने reagent use किया है, if you used the reagent that is dimethyl sulfide, or if you used zinc in presence of acetic acid. ठीक है. So how the cleavage happens is you can do it like this. So what you have done is yes, you can take it here, and meanwhile जो आपका dimethyl sulfide है, it has a lone pair, so it can take this form a plus, so it can go here. So you can form, यहाँ से आपका एक carbonyl बनता है, ठीक, and then you have a carbonyl here formed, and then यहाँ पे you take an oxygen, so it forms dimethyl sulfoxide. So this is your DMSO, which you use the solvent in the organic chemistry. So dimethyl sulfoxide is also formed here. So so basically यहाँ पे पहले क्या बनता है, we have oxygen, we have here that's negative, then sulfur has a plus, then oxygen exists in the form of double bond. Actually ये बनता है ऐसा है, देखिए, it's like this, oxygen has a negative charge, the sulfur by the donation has a plus charge, then they make a bond, so they form sulfur dioxide. ठीक है. So these are the two carbonyl fragments formed. Remember this. So यहाँ पे we know that in the ozonolysis the alkene gets broken down into the carbonyl compound. So this is basically a reductive ozonolysis, because you are using with the ozone you are using the reagent that is basically हम ozone के साथ use नहीं करते, we are using as the workup. ठीक है. So what we do, we use the, it's called as the reductive workup. It's called the workup process. Workup means particularly जब आप organic reactions कर लेते हैं, so first when we set the reaction के बाद जो हमें पहला step में जो मिलता है, whether it is an intermediate or whether it's a new compound, then उसके बाद we purify that, we neutralize that, we add sodium bicarbonate, we add sodium other things. So this process is huge, it's called the workup. तो workup के दौरान if you are adding your dimethyl sulfide or you are adding zinc in presence of your acetic acid, so that's called as the oxidative workup. ठीक है. So oxidative workup में since we use zinc acetic acid or we use dimethyl sulfide, then this mole ozonoid gets broken down, it gets cleaved to the carbonyl compounds. ठीक. This is number one. Now if we talk about the oxidative workup, तो oxidative workup में क्या कर लेते हैं हम, ये जो हमारा mole ozonoid है, this one, so what it does, let's show it here. So if we talk about the oxidative workup, this was our ozonoid, not mole ozonoid. So when you talk about the oxidative workup, we are using the peroxide, which is an oxidant or oxidizing agent. So what it does, simply आपको क्या करना है, it's very simple trick, just break it here. So you will get 2 molecules of stone. यहाँ पे ये remember करना है कि nothing will happen in case of this carbonyl, but if this carbonyl जो यहाँ से बनता है, if it contains a CH bond, then only you will get further oxidized product, that is the carboxylic acid, upon the oxidative workup. If there is no CH bond, then there will be no further oxidation. For example, let's take the example of the oxidative cleavage. If we take the example of oxidative cleavage, for example, if we have our substrate C double bond C H, this is our substrate. So what happens if we treat this with the ozone? So very simple, karna kya hai, we need not worry about the mechanism, this was just for the understanding. Break it here, add oxygen here, add oxygen here. ठीक? Remember we are using ozone and peroxide, that means oxidative cleavage or oxidative workup. So we'll get C, put a double bond here, that is your oxygen. Now in this case also you put a double bond, but remember we have hydrogen on one side, so this will get further oxidized to this compound, that is your acid. So when you talk about the oxidative cleavage or oxidative workup, then ozonolysis in the ozonolysis you get acid also as one of the products along with the carbonyl. Depending on acid kab banta hai, when you have in the carbonyl a CH bond. If there is no CH bond, then you get the carbonyl compounds in both the cases, whether it is oxidative workup or whether it is a reductive workup. Now let's do some of the transformations. So this was the basics. Let's do some of the transformations. For example, if you have a compound like this, so you are asked, let's say you have H here, and then it's shown like this in your exam, ozone here and peroxide here. So what you have to understand is ozone in presence of peroxide. So हमें ये mind में ये रखना है कि it is basically oxidative breakdown. It's oxidative cleavage. It's basically addition of ozone. It forms mole ozonoid. Then it will get converted to ozonoid, and that ozonoid will undergo the oxidative workup. So that means if there is a CH bond present in the carbonyl after breakdown, that will get converted to carboxylic acid. So पहले हमें इसको break करना है. Give it one oxygen. Give it one oxygen. I'm showing the shortcut, so it becomes like this. H. So this means methyl, so make a double bond here. ठीक? So यहाँ से भी जो आपका दूसरा fragment है, that will form the carbonyl. And in this fragment we have methyl group and methyl group here, but here we have one hydrogen. So we have to oxidize this further. So you will get OH. Sorry, H is here. ठीक है? So let's keep it. So you have to oxidize this into OH. So that becomes your carboxylic acid. This is your another molecule, carbonyl and carboxylic acid. That is ketone and carboxylic acid. That's it. Okay? So let's now do one more example, organic transformation. If we have this type of compound. Remember, this is very important. अगर आपके compound में, if you have a triple bond as well as a double bond. Sometimes if ये example आया था, sometimes it was asked in one of the examples, there was some oxygen, there was some silicon, then was this type of group, okay, butyl, so something was there, and then you have this type of compound, and it's written oxygen, that's ozone, and dimethyl sulfide, DMS, or you can write this. So you have double bond also, triple bond also. Remember this, if you have a double and a triple bond present in both the compounds, and that you want to do the ozonolysis in presence of dimethyl sulfide, that means you are going for reductive breakdown, reductive cleavage. So what happens, it is the double bond only that will get affected. Your triple bond will not get affected. So what you do, simple. Get a cleavage here, add oxygen here, add oxygen here. So what you will get, I will only show now this fragment, I will not add this. So यहाँ पे you will add C double bond O. So that means you have hydrogen here, fine. And in this case you have a this hydrogen here, so you will get oxygen. So this is your formaldehyde and this is your another aldehyde. इसके साथ ये fragment attach होगा. Simply break this, add oxygen and add oxygen, that's it. Now अगर यहाँ पे for example if this was the case, यहाँ पे होगा peroxide, then since you have CH bond here also, CH bond here also, you can convert this alt into carboxylic acid, this also you can convert further into OH, that's it. ठीक है. These are another example. Let's take some more example. Let's have a transformation like this. Cyclic double bond here. So it's shown that you are adding ozone in presence of peroxide. So we have to remember that we are using ozone in presence of peroxide is oxidative cleavage. So cleave this here and then you will get so convert this into carbonyl, this also carbonyl. So we have hydrogen here and here also we have hydrogen, and this can further get oxidized to carboxylic acid, this can also get oxidized to carboxylic acid. So your product is basically like this, H, and then this way also you can write COOH, that's it. So you can get the two carboxylic acid groups here. So let's now do the organic transformation, further examples of this ozonolysis. So let's do some more examples. Okay. So let's have examples like अब यहाँ पे एक special case है of transformation. Let's have a case like this compound. So we have two double bonds in the compound. We have a methyl group here. This was also asked in the exams, the CSIR paper some time back. It's a methoxy group here. So we have two double bonds, but both the double bonds are the substituents. But problem is that we have methoxy group here, which is a strong electron donating than the methyl. So this double bond is more electron rich compared to this. So इस case में क्या होगा? If you have written like you are adding ozone in presence of dimethyl sulfide, so you are basically doing the reductive ozonolysis. That means जो breakage के बाद fragment मिलेगा, we need not to oxidize that. So what will happen? यहाँ पे rule ये है, the one which is electron rich, that only will get cleaved. Remember this. So when you have two substituents, that's two double bonds in a compound, the one which is more electron rich, that will get cleaved. So cleave this one, it's more electron rich, so cleave this one. This will remain unaffected. So you will get, so this is your unaffected. So here you have OMe. So cleave this, get oxygen here and get oxygen here. So it's OMe, oxygen. And in this case, this one, so you have C double bond O and H. That is the product formed. Now, if for example, instead of DMS, it was peroxide here. Now you have H here, so you can convert this into carboxylic acid. That's your final product. Okay. Likely, if you have case like some more cases, let's say we have peroxide we have done. If you have case like yeah, very important. For example, if you have this type of transformation, this was also asked. All these transformations जो मैं discuss करता हूँ, they have been asked in previous exams. इसी के आसपास पेपर आता है, so new things will not come. Usually these are the areas where from the question is asked. So we have a double bond here. ठीक? So we know that, and it's written like you have ozone here. अच्छा, दूसरी बात ये है कि if only ozone is written on the arrow, it means it is reductive. Remember this. So it doesn't mean that it's oxidative. So if it is only ozone, that also means reductive. If it is ozone and then DMS, it's also reductive. If it is peroxide written, that's called oxidative cleavage. ठीक? So it's ozone, that means reductive. So simple what we have to do, we have a double bond here, cleave it here, add oxygen here, add oxygen here. So what we'll get? This is one compound. So this is HH, and then second compound is, your product is like this. That's your product formed. Okay. Now this is what is the product formed. Then you have another case. So for example, if it is like this, and then you have double bond here, and it's shown like oxygen dimethyl sulfide. So it's a reductive cleavage. So when there's reductive cleavage, double bond is here, break the double bond, add oxygen on this side, add oxygen on this side. So what you can get, product without wasting time is do like this. So this is your double bond here, and you have a double bond here. That's it. Okay. So these are many processes what you can do. Now you have a special case is if we have an alkyne formed, or we'll do that in the end. Just do one more example. Alkyne case will do end. Sometimes people question aata hai. If your question is you have a benzene ring here, and you are treating this benzene ring with three equivalents, that is like that, three equivalents of ozone. इसका मतलब 3 molecules of ozone add हो रहे हैं. So when there are 3 equivalents of ozone, इसका मतलब 3 double bonds पे they will act. So breakage will occur along all the double bonds. So what you do, this will get broken down, this will also get broken down, this will also get broken down. So you will get यहाँ से भी one oxygen, यहाँ से भी, so this is one molecule. You will get another molecule. So you get 3 molecules, and everywhere you have this type of structure. And then automatically you have hydrogen here. So you are basically getting 3 molecules of this compound, which is called as glyoxal. So that's your glyoxal. A important question. Benzene, reductive cleavage with ozone, that gives glyoxal, 3 molecules. But remember, you're using the 3 equivalents. Okay. Let's say we have example like so this was normal. Yes. Now we have some special reactions as far as the ozone is concerned. Unexpected product based applications. These are example you have been asked. So now we have the case of unexpected products. In the unexpected products during the ozonolysis. इसके लिए we'll do reaction number 1. कब unexpected product बनता है? Number 1 case. If you are doing ozonolysis of alpha beta unsaturated carbonyl compounds. If your substrate is alpha beta unsaturated carbonyl compound, so in case of alpha beta unsaturated carbonyl compounds, if you do the ozonolysis, then इसमें याद रख लीजिए, you will get the product which has 1 carbon less. So the product will be having 1 carbon less, 1 carbon atom less. Remember this. In case of alpha beta unsaturated carbonyl compounds, if you do the ozonolysis, then the product which is formed as per the normal procedure, but that will be having 1 carbon less. For example, if you have this type of example, जो question exam में आया था एक बार, this is your alpha beta unsaturated carbonyl compound. And then there is something on this side, whatever we can keep on this side. ठीक है, यहाँ भी कुछ था, but I'm not showing that. So it's like this. Ozone. And let's say you are using oxidative cleavage. ठीक है. So rule क्या है? If you have unsaturated alpha beta unsaturated carbonyl compound as a substrate, and then you are using ozonolysis, oxidative cleavage, ozonolysis on that substrate, so the product which is formed as one carbon less. So आप क्या करोगे यहाँ पे? Simple. You have to break this double bond. ठीक. So once you break the double bond, then you will get carbonyl here. Okay. So the normally this is what you expect. You expect I will break, you will get a carbonyl here. Let me make it here. थोड़ा सा completely was asked in the exam. ठीक है, yeah. So you break this, so you expect that your product will be like this. That's your this ring. So then you have carbonyl here because you have broken this. Get oxygen here. ठीक है, तो यहाँ से so you have how many carbons? 1, 2, 3 and 4 carbons. But यहाँ पे you'll be only having 3 carbons. 1, 2, 3, 4. 1, 2, 3. Since you will get aldehyde, so यहाँ से you will get H. So जब H बनेगा, so that will get further converted to carboxylic acid because using peroxide. So this is your product formed. That's it. So होना क्या चाहिए था? Normally since you are breaking here, यहाँ पे actually क्या बनेगा? You will get oxygen here. So you will get this type of product. Let me just show it first. You get this type of thing. Should be like this. ठीक? Since you have H here, so this will get further oxidized because you're using peroxide, so you get a carboxylic acid. But this will get removed. When the CO gets removed, that means now this has 1 carbon less. So that's why I have shown like this. Why it gets removed, that's a long process, so I'm not going to discuss that. Just remember, if you have an alpha beta unsaturated carbonyl compound as a substrate in the ozonolysis, the product which is formed, it will be having less 1 carbon atom. So that's your unexpected product. This question I thought was asked many times. Now there is one more unexpected type of ozonolysis transformation, that is if you have a allylic alcohol. So if you have substrate as a allylic alcohol, and जिस पे आप reaction कर रहे हैं ozonolysis, if that is a allylic alcohol, so what will happen? Let's take the example that was asked in the question paper. This is something that was asked. ठीक है, so question इस तरह से आया था. So you have there also a methyl group bold, then you have this alcoholic group. So double bond, then single bond, then alcohol. So this is called as the allylic alcohol. Fine. So substrate has a double bond, but then we have at allylic position OH group. So this is allylic alcohol as a substrate. And if it is like this, that is written on the arrow, you are dealing with ozonolysis. जैसे मैंने पहले भी कहा, so if it is reductive ozonolysis, so oxidative ozonolysis, then it is peroxide. So what we do, normally we'll break it here normally. ठीक? So if it break it here, you expect the product should be like this, that you should get a carbonyl on one side, and then on this side you should get this type of product. ठीक? तो normally we expect this. अब मैं यहाँ से इसको बनाऊंगा नहीं further, rest will remain seen, but it is not the case. ये तो बनता है in this case, लेकिन ये जो बनता है, it is not formed as it. Something else is formed. क्या बनता है? Let's see it. So if this is your substrate, you are adding the ozone. Let's first make the the mole ozonoid here. So what will happen? we'll have this type of, when you add the ozone you will add like this. तो पहला स्टेप तो इसको नॉर्मल ऐसा है. So you added the ozonoid, and on this side you have this structure. ठीक है. This is your step number 1. Now after that, what you do when you do the cleavage, जैसे आप cleavage इसमें कर लेते हैं, after that, so sorry, we have alcoholic group here. This alcoholic group. So when you do the cleavage in this case, because you are doing the cleavage, sorry, this is a single bond now because you have added the OH here. So then what you do is you cleave this bond here, then you bring it here. So when you cleave the bond here, this oxygen, जब आप इस पे प्लस आ जाता है यहाँ पे, so this will get stabilized. So this will make a carbonyl here. ठीक है. So what you will get from here, okay, we'll make this portion also. So we'll get, so when you get like this, so you have, this is your this cyclobutane, then you, this is C, you have carbonyl here, oxygen negative. ठीक है. So then this portion, यहाँ पे you have this one, then you have carbonyl here. So this is your group. So this is your carboxylic acid. ठीक है. So on this you are getting the carboxylic acid fragment on this side, and this side you are getting the carbonyl group. So this is your, and then this will get protonated to form carboxylic acid group. On this side you have the carbonyl, and then this is as usual. So this is the product formed. So it's basically because इसमें reason क्यों है why this unexpected product is formed, it's because you have the alcoholic group. Once you cleavage this ozonoid, once you cleavage this mole ozonoid, so this bond, once it gets broken during this transformation, the OH group that actually creates a double bond here. ठीक है. So because positive charge gets generated here, then this donates the lone pair to form the double bond. That's why we have the unexpected product formed. So this is your product formed. Normally हम क्या expect कर सकते हैं कि this should not get broken down, but we have cleavage of this ring also, and then obviously second product is as expected. So this was all about your the unexpected products. Now we have one more unexpected product, that is if you have substrate as your carbon-carbon triple bond. So this is also a bit interesting. If your substrate is carbon-carbon triple bond, if it is not a double bond, it's a triple bond, and then you are using ozonolysis. तो एक formula तो normal है, it will break these two bonds and then we'll get CO here and CO here. That's simple. So we can get like this: C double bond O, C double bond O, then R, and then R. This is one. Normally, if we take alkene into our mind, breakage of C double bond C generates C double bond O, C double bond O. Since we have a third bond also here, that will not get broken, so this is one of the products formed. But it also breaks sometimes this compound. If we break this further, for example, if some of the molecules are getting broken down, then what we'll get? We'll get CHH. So it's CH, so it will get also further oxidized. ठीक है. So you'll get carboxylic acid. So you'll get this molecule also, and you will get the carboxylic acid molecule also as the product formed. In fact, carboxylic acid is the major product. Remember this. So if you talk about the ozonolysis of alkynes, for example, this type of alkyne, then the carboxylic acid is the major product in addition to the 1,2-dicarbonyl compound. So simply break these two, get this compound. So this this will be also on the products, but then some of the molecules will further get cleaved to form the carboxylic acid. So ozonolysis of alkynes can form 1,2-dicarbonyl compounds as well as the carboxylic acids. And carboxylic acid is the major product in case of ozonolysis of alkynes. That's it. So this was the major portion जहाँ से question आता है regarding the ozonolysis. इसमें we have to remember, I think, the very simple as that. If there's a bond, ये तो इसका basic है, and in presence of ozone, if it is O3 and then it is peroxide, so it's oxidative cleavage. Break it down, get oxygen here, 2 carbonyls. उसके बाद we have to remember, if we have H here, if one of the substituents is H and we are using this peroxide, then जो molecule H के साथ that will get further oxidized to OH, that's a carboxylic acid. And if it is here dimethyl sulfide, that's the reductive ozonolysis, then both the carbonyl compounds will be formed and there will be no more further oxidation. Then if we talk about the unexpected products mean number 1, if you have 2 double bonds and the one which is electron rich, वहीं पे only ozonolysis will take place and then a normal product is formed. Then if we have case like alpha beta unsaturated carbonyl compound, so the ozonolysis will take place as normal, but we have to remember that the breakage will take place. जो आपका product बनेगा that will be having less 1 carbon atom as normal. Then in case of allylic alcohol, just remember this one example. It's very, very unexpected that this breakage will lead to 1 molecule of this, but further normally we expect that should have a carbonyl here, but that's not the case. It further gets broken down, then you will get aldehyde from this portion and this will get oxidized to carboxylic acid. So this is unexpected. And in case of your alkynes, the ozonolysis leads to the formation of 1,2-dicarbonyl compound and also major product as carboxylic acid. Just break it down and get to carboxylic acids. So इसका जो mechanism है that I already discussed, let me get it back here. So the mechanism is concerned. So in the mechanism we have first formation of mole ozonoid, then it gets transformed to this intermediate. It's called as a Criegee's intermediate. So in the ozonolysis of alkenes we have the Criegee's intermediate formed, which is a Zwitter ion structure. Then that Criegee's intermediate further undergoes the transformation to form the ozonoid, and then that ozonoid breaks to the carbonyl compounds. Okay? So this was all about the ozonolysis of your unsaturated compound, that is the alkenes. Ozonolysis of alkenes occurs in the form of oxidative form or a reductive ozonolysis. Oxidative means you are using peroxide and in the workup, and reductive means you are using dimethyl sulfide or zinc acetic acid in the workup, so that's your reductive. In case of oxidative, if you have H present in the carbonyl, that gets converted into acid, and in case of reductive, your reaction stops at the carbonyl stage only. So this was all about the ozonolysis, जहाँ पे question आता है in your competitive exams like CSIR, NET, GATE, JRF exams. If you feel any confusion, any questions, any other problems that was asked in the previous exams, you can write down in the comments. ठीक है? So thank you regarding this class of the reagent series.